Hey VC students, welcome to another video of hok'stutoring. I hope you're doing well and enjoying your studies. Today we'll be going through a crash course on factorization. So this is one of the most crucial mathematical technique that you want to stay on top of and one that you want to master by the time you start doing your SACs and definitely by the time you do your exams. A lot of students might think that they know their factorization, they know how to factorize, but I can tell you that you don't just want to know it, you want to master it. So a lot of students tend to struggle with in terms of efficiency and speed when they're factorizing, and some students just get lost. There's so many different techniques with factorizing that they don't know which one to apply. So in today's video guys, I'm going to summarize, this is more towards your VC methods and spec students. I'm going to summarize how to factorize polynomials, the different techniques and which ones to apply in your different scenarios. I'm going to show you the tips and tricks on using these techniques and which one to apply first and which one to consider last. Okay, so guys, I hope you find this video useful. If you do, watch till the end and leave a like and subscribe to the YouTube channel. I would really appreciate this. But without further ado, let's get into factorizing. Well guys, first of all, what exactly is factorization? Well, factorization is the art of writing a mathematical object or expression in the form of multiple factors. So in methods and spec, what this normally means is you're going to be converting a polynomial expression, so your x squared, x cubed, x to the power 4, x to the power 5, blah blah blah, into linear factors, and in some instances into quadratic factors if you can't factorize those further down. But essentially it is making something that looks really big into chunk size, and those chunk size are linear factors usually. So in today's video guys, I'm going to break down how to factorize quadratic equations, and then I'm also going to show you guys how to factorize cubic equations. Alrighty, so with quadratic expressions, there are two main types of factorization, and I will list them in order of efficiency and speed. So the first one will be the fastest one, the one that is your go-to every single time, and you need to try to see if you can do this first before jumping into the second one, which I will label as B. So the first method of factorization for quadratics is what I call the crisscross method. Some of you might have heard it. And the second one is what we call complete the square. Okay, complete the square. Alrighty, so with the crisscross method, and we'll go through an example, and I'll give you one over here. The technique essentially is you look at the first term and you look at the third term. So the first term is always the one that has x squared, and then the third term is always the one that has just the number. Okay, and specifically you look at the coefficient of them. Right, so how do you apply crisscross method? In using this method, you look at the coefficient of the first term and you try to get factors of it. So in this case, the coefficient here is 1. And in this case, the factors of 1 can only be, well, 1. So I'll call it 1x, and the other one is 1x. You write it in this format, and then you look at the third term, and you also look at the, what are the factors of 2? So you can only get 1 times by 2 to get you 2, right? So those are the two factors of 2. So you put them in order, either 1, 2 or 2, 1. You need to play around with it. And then what you do here is you crisscross, okay? So you aim and try to see if I multiply in a crisscross format, x multiplied by 2, which is 2x, and then x multiplied by 1, which is x. And because they're all positive number, if you try to add these numbers together, can you get the middle term? So in this case, if I add 2x and x, I actually do get 3x, which is indeed my middle term. And that means your numbers over here, the 4 numbers over here, are actually correct. And then your factors in this case for this expression over here is the first x over here, and then you just take it across, okay? So in a row, and that number 1 is a positive number, so you go x plus 1. And then multiply by, you go to the second row, so it's x again, and then you go across and you get plus 2, because again 2 is a positive number. And guys, this is then how you split the quadratic expression into linear factors. Okay, so that's using the crisscross technique, and I'll go through another example here just so that you have a full understanding of how to apply this technique. So another example is if we have 2x squared minus 7x minus 4. Alright, so this one's a little bit more complicated than the first one, but again, the same technique. You look at the first term and then the last term, okay? So, right, so now we need to think, okay, what are the factors of 2x squared? Well, there's only one way you can think about this. There's two ways, 2x and x. Or you can think of it as negative 2x and negative x, because the negative, when they multiply by each other, actually cancels out and becomes a positive. But for the sake of this, we'll stick with positive first and see if it works. If it doesn't work, then we can try the negative numbers. But generally positive first because it's easier, and usually you might get an answer. Now we look at the last term, the third term. So what are the factors of negative 4? There's actually multiple different pairings you can get here. You can get negative 4 and negative 1, negative 4 and positive 1. You can get positive 4 and negative 1, or you can get 2 and negative 2, right? So those are your three different pairs of factors that can get negative 4. So then we need to try and combine or pick the right pair so that when you crisscross and then you add them up together, the product of your crisscross, you get the middle term negative 7x. And this is all about practice, guys. The more practice you do, the more the more instinctual this becomes, and you can generally pick the right pair. So if you try 2 and negative 2, unfortunately you can try crisscross, it wouldn't get you negative 7. So if it's negative 2 and 2 here, what you get is negative 4x. Crisscross that, you get plus 2x, and then you don't get negative 7 at all. See, because negative 4x plus 2x only gets you negative 2x, not negative 7. So you need to try a different pairing, and it comes with practice. But the pairing that you want to try here is you want to get close to negative 7. So what can you do? You pick the negative 4, right? Because negative 4, if I was to put it over here and I crisscross eventually, then 2x multiplied by negative 4 gets you negative 8, which is really close to negative 7. And what do you have? You have that 1, right? Which is going to get multiplied by that positive x. And you can try it over here. 2x times by negative 4x gets you negative 8x. X times by 1 gets you the positive x. And then when you add them up together, you do get the negative 7x, which is the middle term. So then your factors, guys, for this, again, go to row 1. 2x, and that's a positive 1, so you get 2x plus 1. And then you go to your second row, multiply by x, and this is negative 4, so you minus 4 there, okay? So guys, that is the crisscross technique. It is generally the easiest, easier of the two over here. And it's, the more practice you do, the faster you become at this. Unfortunately, the crisscross technique does not solve everything. It does not work on every polynomial. So that is why we have the second technique, complete the square. Complete the square pretty much can factorize any, or not any, can factorize pretty much most polynomial expressions into linear factors. And I'll show you guys how to do that over here. So part B, where we have the crisscross. So with the crisscross technique, what you do essentially, and I'll give you the same kind of example, right? X squared plus 3x plus 2. X squared plus 3x plus 2. So with complete the square, we need to first of all take advantage of the fact that if I have an expression, for example, x plus a square, then if I was to expand that, then I get 2ax plus a square, right? And vice versa with the negative, if I was to expand that, I get x squared minus 2ax plus a square. And then you also have x squared minus a square, which you would then get x minus a multiplied by x plus a. Okay, so these are the three formulas that we essentially are the theory behind how we apply the, complete the square technique. So to start with completing the square, step number 1 is you need to rewrite the first two terms, so x squared plus 3x, and then you halve the coefficient of the second term and square it. So in this example, the coefficient of the second term is 3, So I half that, I get 3 over 2, and then I square it, okay? So what you do afterwards is, because you're adding a term, you have to subtract it as well, okay? So in this case, this number right here should not exist, and therefore if we have a positive, we need to also take away the exact same one so that it should be 0, and we rewrite the plus 2 at the end, because essentially writing this expression over here as this is the same, okay, but just a longer way of writing it, because at the end of the day these two terms will cancel out. So that is your step number 1. You halve the coefficient of the second term, and then you square it, but then make sure you subtract that as well, and then just write the expression as it is, okay? And then step number 2 is we apply this theory over here, right? If I have a format, an expression that has x squared, a squared, and in the middle of it is 2ax, so 2 multiplied by the first term, multiplied by the second term without the squares, then you can see that in this first 3 terms, that is exactly the same format. You've got the x squared, you've got the a squared, which is over here, and then if you multiply the x and the a by 2 as well, then you actually get the middle term. So we can have a try. X squared essentially is this one. 3 over 2 square is essentially a square, and then 2ax is, you get 2 multiplied by a, which is 3 over 2 without the square. So 2 times 3 over 2 is 3, and then you multiply by x, so by x over here you get 3x, right? So you can rewrite this first expression as x plus a square, okay? So x plus 3 over 2 square, and then now with these two other numbers at the back, right? So the 2 terms at the back, what do you do with them? Well, you just add or subtract them together. So in this case, 3 over 2 squared is 9 over 4. You get negative 9 over 4 plus 2. And I'll do it on the side. Negative 9 over 4 plus 2 is the same as negative 9 over 4 plus 8 over 4. And you get negative 1 on 4. So in this case, this expression now becomes bracket of x plus 3 over 2 square minus 1 on 4. And then the third step, guys, and yes, this technique again, it seems to be quite long, but that's why it's your second technique. Although it captures more, you can factorize more terms than your crisscross. So now we take advantage of this theory over here, or this formula over here. If I have a term that is squared minus another term that is squared, you might not see a square here, but essentially you can write that as x plus 3 over 2 square minus 1 over 2 square, in fact, right? Because 1 over 2 square is 1 over 4. And then there we go, you actually have an expression that now looks like this formula, x squared minus a squared. And what does that become? Well, you can see over here, right? It's just x minus a, and x in this case is everything here in this bracket, and then minus a, so in this case you get minus a half, times by again, so it's the first term, so in this case x plus 3 on 2, and then you plus the a, so plus the half, the second term, right? And then now you just need to simplify them. So x plus 3 over 2 minus a half, you get x plus 2 over 2, which is x plus 1. And then over here, you get x plus 3 over 2 plus a half, which is x 4 over 2, which is x plus 2. So guys, there we go. That is how you use the complete the square technique, which you end up with the same answer, x plus 1, x plus 2, same as what you got for crisscross. So this technique, again, if your crisscross doesn't work, then you can apply this formula over here. And usually you will get something, okay? The only way that if you can't turn into linear factors, then essentially that quadratic expression can't be factorized into linear factors. You can't do anything with it. So that's pretty much it, okay? So guys, that is the first part of this video. I'm gonna cut it short so that it's not too long, but that is how you factorize quadratic expressions. In the next video, we'll learn how to factorize the cubic expression, which is going to take advantage of what we learned today. Alright, so thanks for watching, guys. I hope you enjoy. Please follow on to part 2 if you want to learn how to factorize cubics. I will see you there in the next video. Thanks for watching.